Lesson 3.4, Dividing Polynomials. In this lesson, we'll use division to help determine zeros of a big polynomial function. When we use division, we're starting off with what's called a dividend. And a dividend is your original polynomial or number. And then what you do is you divide by what's called a divisor. I know, catchy name. So the divisor is what you divide by. Now the answer you get is called the quotient. Hopefully that sounds familiar to you. That's just your answer. And when you divide, if there's something left over at the end, that's called the remainder. So anything that's left over at the end. We'll start with something that hopefully looks familiar to you from very early math classes when you first learned about division, and then we'll transfer that idea to polynomials. In our first example, it says divide using long division. 1,569 divided by 13. Now you're only going to use a calculator just to figure out what possible factors are. You're not going to actually do the division and have a decimal. When we write this out, the first number is your dividend. What you divide by is the divisor. That number will go on the outside. And then, does this look familiar? Dividing by or drawing in like a big division bar? We'll put the dividend on the inside. To divide using long division, take the term on the outside and match it up with as many terms on the inside that it'll go into. 13 will go into 15 one time. 1 times 13 is 13, and then you subtract. 15 minus 13 is 2. Bring down the 6. Now 13 will go into 26 twice, and it actually goes in evenly. So then you have 0 as your remainder, but when you bring down that last number 9, notice 13 doesn't go into 9 at all. That means 9 is the remainder. To write this out then as your quotient, you would say 12 with a remainder of 9/13. That would be your final output. If that looks familiar with just numbers, it'll be that same process with polynomials. Your dividend is going to be the big polynomial like a cubic or a quartic function. Your divisor will be the smaller polynomial that you're dividing by. That will go on the outside. You put a pretty big fraction bar or dividing bar on this one and write your dividend in on the inside. X cubed plus 5x squared plus 6x plus 9. And it's important to note here, you guys, that all terms must be represented in your original dividend. If there's a term that's missing, you have to put in 0 as its coefficient. So it needs a placeholder. Okay, to do this division, take just the first term on the outside, not the entire thing, just the first term, and the first term on the inside. What could we multiply x by to equal x cubed? We could multiply it by x squared. So once you know what to multiply by, distribute it into that first part and the second part. X squared times x would give us x cubed. You always want that column to match initially. X squared times 3 would be positive 3x squared. And if you recall from long division with plain numbers, you always subtract this row. So when we do that, I'm going to subtract this one and this one. Change both their signs. That first term or that first column will always cancel out. Then we have 5x squared plus negative 3x squared, which is just subtraction. 5 minus 3 would be 2. We have 2x squared kind of left over. Bring down that next term just like we would a number, but we'll just bring down the entire term. Again, take that first term on the outside and that first term on the inside. What could we multiply x by to equal 2x squared? Well, we would need to multiply it by a positive 2 and an x. Once again, distribute that to both terms. 2x times plain x would be 2x squared. We get a match in that first column. In the second column, notice what happens here. We get 2x times 3, which is plus 6x. Again, subtract that row. And in this case, not only do the numbers in the first column cancel, but the numbers in that second column also cancel. Dropping down what's left over, we just have 9. Now x can't go into 9, which means 9 would be what's left over. And again, that is the remainder. To write out your quotient now, we write out everything that's on the top. X squared plus 2x. And then since 9 is positive, we'll put plus 9 over x plus 3. That would be your remainder. And that's long division with polynomials. Let's try another one. 8x to the third power plus 27 divided by 2x plus 3. The first number is your dividend. The second number is your divisor. Now the divisor is going to have to go on the outside. 2x plus 3. Draw your big dividing bar. Notice the dividend initially has terms missing. We go from 8x cubed to a constant of 27. That means as I write it out, 8x cubed starts us off, and we're missing the quadratic term. I'm going to put plus 0x squared just as a placeholder. In this one, we're also missing the linear term, so I'll give that a 0x, and finally plus 27. As we go through that process, see if you can follow what we did similar to that last example. Take the first term on the outside and the very first term on the inside. What could we multiply 2x by to equal 8x to the third power? Well, 2 times 4 would give us 8, and x squared times x would give us x cubed. This would be 4x cubed. 4x squared, sorry. And if we multiply it by 2x, we get 8x cubed. Distribute that to the second one as well. 4x squared times 3 would be 12x squared. And remember, at this step, you subtract this row, which means you just change all of your signs. That'll always cancel out that first column, and then you're just kind of stuck with what's left over for the rest of it. 0x squared minus 12x, sorry, I was getting ahead of myself, is negative 12x squared. And then I'm going to bring down 0x. What could I multiply 2x by to equal negative 12x squared? I'd have to multiply it by negative 6 and x. If I distribute that all the way to that first term, there's our negative 12x squared. And if I distribute negative 6x to positive 3, that gives me negative 18x. As I subtract this time, now my signs both change to positive. It's just always the opposite of what it was originally when you subtract that row. The first column cancels, and let's see what's left over. 0x plus 18x is just 18x. Drop down that plus 27 as our last term in that dividend. One more round. 2x and 18x. What could we multiply 2x by to equal 18x? We could multiply it by positive 9. One more round of distribution. Distribute the 9 to the 2x. That gives us our 18x, which we wanted to match. And now look at this, you guys. 9 times 3, voila, is 27. As we subtract this last row, not only does the first column cancel out, but the second column cancels out, and there's nothing else to drop down. That means our remainder is 0. Our quotient then is just 4x squared minus 6x plus 9. That means the divisor goes in evenly to the dividend. And notice that our quotient has one less degree than our original dividend did. And we'll call that good for our video today. Tomorrow we'll talk about synthetic division as an alternative to long division in class.